Namaskaram to all. Today we are going to see about the preparation of phenol and properties of phenol. First preparation, Dow process. It is from chlorobenzene. When the chlorobenzene reacted with the sodium hydroxide, the sodium hydroxide is split into NaO and H. That H reacted with the Cl of chlorobenzene, so that we are getting sodium phenoxide when they are reacted under 633 Kelvin and 300 bar. Now the sodium phenoxide again reacted with the HCl. That again we are going to split the HCl as a H and Cl. The Cl alone reacted with the sodium of sodium phenoxide, so that we are getting phenol and sodium chloride. The next one is from benzene sulfonic acid. The benzene sulfonic acid is reacted with the sodium hydroxide under 623 Kelvin. First of all, we get the sodium phenoxide. Afterward, when the sodium phenoxide reacted with the HCl, the Cl alone react with the sodium. Afterward, we get phenol as a product. The next preparation, from aniline to phenol. Aniline formula is the benzene is attached with the NH2. It is reacted with the nitrous acid. Nitrous acid we are getting from the reaction between sodium nitrite plus HCl. This reaction undergo 273 Kelvin to 278 Kelvin. Now we get the benzene diisonium chloride as a intermediate. When the benzene diisonium chloride is reacted with the hot water and in presence of mineral acid, we get phenol plus nitrogen plus HCl. In benzene diisonium chloride, it have two nitrogen. The two nitrogen is removed as N2, and Cl is reacted with hot water. We split the hot water as a H and OH. That H alone reacted with the Cl of benzene diisonium chloride, so we get HCl, and remaining OH is attached with the benzene ring, so that we are getting phenol. Now the next preparation is from cumene. The cumene reaction is a very important question. First of all we get the cumene from when the benzene is reacted with the propene or propylene. Propylene is a common name. When in the presence of phosphoric acid and 523 Kelvin, we get cumene. What is cumene means? Isopropyl benzene. That again that isopropyl benzene in the presence of air and 5% aqueous sodium carbonate, we get cumene hydroperoxide. Cumene hydroperoxide means just we are going to add 2 oxygen in cumene. That afterward, when we add sulfuric acid, I indicated as a line whatever product or we are going to get as here means acetone and phenol. The chemical properties of phenol. First of all, we are going to see the reactions involving OH of the phenol group. First of all, the phenol when reacted with the zinc dust, the zinc alone take away the oxygen of phenol, so that we get the benzene as a product. It is important question. The next one, when the phenol is reacted with the ammonia in the presence of anhydrous zinc chloride, the ammonia we are going to split as the hydrogen and NH2. The hydrogen reacted with the OH, so that we get water. We have to remove the water. Afterward, the OH is replaced by NH2. Now the product name is aniline. Aniline means benzene is attached with the NH2. The next reaction is Cotton-Bowman reaction. This reaction is used to convert the phenol as a ether. Now when the phenol is reacted with the acetyl chloride formula CH3COCl. Here we are going to remove HCl. I indicated the HCl in that line in the presence of sodium hydroxide and pyridine. Now we get remaining reactant we have to attach, so that C6H5COOCH3. That COOCH3 is called as acetate and C6H5 is called as phenyl. So the product name is phenyl acetate. This reaction is called as acetylation of phenol. The next one, when phenol is reacted with benzoyl chloride formula C6H5COCl. I indicated whichever is going to remove. in the presence of sodium hydroxide and pyridine, the HCl is going to be removed, so that we getting the product like C6H5 COO C6H5. Here the COO C6H5 is called as benzoate and C6H5 is called as phenyl. So the product name is phenyl benzoate. The next reaction is Williamson's ether synthesis. In this reaction, when the phenol is reacted with the sodium hydroxide, we are going to remove the water from sodium hydroxide OH and phenol gives H. So instead of that H, we are going to add sodium. So the product we are getting sodium phenoxide. Afterward, the sodium phenoxide is going to add with the methyl iodide. Here the methyl iodide, the iodine alone attached with the sodium of sodium phenoxide, so that we are getting as a sodium iodide. That sodium place is occupied by methyl. This product name is anisole, or another name is methoxybenzene. The next one is oxidation. Oxidation reaction means we are going to remove the hydrogen here. In the presence of potassium dichromate and concentrated sulfuric acid, phenol undergo oxidation reaction, so that here we are going to remove the hydrogen. So we get 1,4 benzoquinone. The next one, reduction reaction. What is the meaning of reduction? Means addition of hydrogen. So in the presence of nickel under 160 degrees Celsius, phenol added with hydrogen, we get cyclohexanol. Here the double bond is removed because we are going to add hydrogen, so that the double bond is removed, we get the product cyclohexanol. Now we are going to see the reactions involving benzene ring of phenol. Phenol undergo electrophilic substitution reaction. First reaction, nitrosation. When phenol reacted with the nitrous acid under low temperature, that is 278 Kelvin, it gives para-nitrosophenol, that is phenol along with the NO in para position. Nitration of phenol. When phenol reacted with the 20% of nitric acid in 298 Kelvin, it gives orthonitrophenol and para-nitrophenol. Orthonitrophenol gives 30 to 40% yield, but para-nitrophenol gives 15 yield. And difference between these two are, one more differentiation is, orthonitrophenol is slightly soluble in water and more volatile. Why? Means it is intermolecular hydrogen bonding is present in orthonitrophenol, where in para-nitrophenol it is more soluble in water and less volatile. Why it is? Means because of intermolecular hydrogen bonding is present in para-nitrophenol. So because of this differentiation between these two, we can separate this orthonitrophenol and para-nitrophenol by steam distillation. Next one, preparation of picric acid from phenol. It is important question. When the phenol is reacted with the concentrated sulfuric acid and concentrated nitric acid under 298 Kelvin, it gives picric acid. The formula for picric acid is given there, and for IUPAC name is 2,4,6 trinitrophenol. If you put the number in 1 in hydroxy, the second number goes to NO2 and fourth number goes to NO2 and sixth number goes to NO2. So that we are getting the name 2,4,6 trinitrophenol. Reaction is sulfonation. When phenol reacted with the concentrated sulfuric acid, it gives two products. One is orthophenol sulfonic acid, another one is paraphenol sulfonic acid. But the orthophenol sulfonic acid has a major product when it is undergo under the Kelvin 280 Kelvin. Suppose we need the paraphenol sulfonic acid as a major product, means we have to react the concentrated sulfuric acid with the phenol under 373 Kelvin. The next reaction, halogenation of phenol. When the phenol reacts with the bromine water, it gives white precipitate of 2,4,6 tribromophenol as a product. Suppose the reaction is carried out when the phenol is reacted with the bromine under carbon disulfide or carbon tetrachloride at 278 Kelvin, we get two products. One is orthobromophenol, another one is parabromophenol. Next reaction is Goldschmidt reaction. This is important reaction. When the phenol is reacted with the sodium hydroxide, the sodium hydroxide split into sodium and OH. That OH alone react with H. We remove water. The sodium automatically added with the phenol, so that we get sodium phenoxide. Afterward, the sodium phenoxide react with the carbon dioxide under 400 Kelvin and 4 to 7 bar pressure. We get sodium salicylate as a product. Now that sodium salicylate is going to acid hydrolysis, that we get the final product salicylic acid. This is the Goldschmidt reaction, important reaction. The next reaction is Reamer-Tremor reaction. When the phenol is reacted with the chloroform CHCl3 under aqueous sodium hydroxide, it gives substituted benzoyl chloride as an intermediate. Afterward, the sodium hydroxide introduce the aldehyde group in the ortho position, so that we get the product salicyl aldehyde. This reaction also one of the important reaction in phenol. Another important reaction in the phenol is phenolphthalein preparation. That phenolphthalein is prepared when the phthalic anhydride, the phthalic anhydride formula is given here, is reacted with 2 moles of phenol. One of the hydrogen is projected in that phenol. So we are going to remove the water in the presence of concentrated sulfuric acid. This concentrated sulfuric acid is a important dehydrating agent, so that the water is removed like that. So we get phenolphthalein. See the product here. Another important reaction is coupling reaction. Benzene disonium chloride is coupled with phenol under sodium hydroxide under 273 and 278 Kelvin. We get red orange dye, that is para hydroxyazobenzene. Here we are going to remove the HCl. One of the hydrogen in phenol is projected. That hydrogen is reacted with the Cl of benzene disonium chloride, so that we are getting para hydroxy. The hydroxy is in the para position, and azo means 2 nitrogen. The 2 nitrogen is present in the between the 2 benzene, so that the product name is para hydroxyazobenzene. Differentiation between alcohol and phenol. Phenol react with the benzene disonium chloride. It gives red orange dye. But when ethanol react with the benzene disonium chloride, it does not give any coloration of dye. The second one, when phenol react with the neutral ferric chloride solution, it gives purple color. The same way, the alcohol react with the ferric chloride, it does not give any coloration. The third one, the phenol react with the sodium hydroxide, gives sodium phenoxide. But in ethyl alcohol, it does not react with the sodium hydroxide. Now uses of phenol. First uses of phenol is Paclite. What is Paclite means? It is phenol formaldehyde resin. The next one is this phenol is used in the preparation of phenacetin, salal, aspirin. These are the drugs. The next one is phenolphthalein. Phenolphthalein indicator is prepared with the help of phenol only. The next one, picric acid. It is used as a explosive. This picric acid also prepared with the help of phenol. The third one, the phenol is used as a antiseptic, that is carbolic lotion and carbolic soaps.